So guys, this is a Hess's law calculation. The combustion of methane is described by the following balanced equation. CH4, which is methane, 2O2 produces carbon dioxide and 2 waters per 1 methane molecule. There's the heat of reaction, so we're not going to be asked for that in this question. So let's see what we're asked. The standard heats of formation of carbon dioxide and water are that. Don't forget that that's the order of them. The order is carbon dioxide and then water. You see that word respectively, so just be careful that you're clear on which is which. Calculate the heat of formation of methane. So we'll go back to this, our useful formula. Delta HC, in this case the heat of combustion, is equal to the sum of the heats of formation of the products minus the sum of the heats of formation of the reactants. So in this case, the delta HC is what we're given, minus 890. So it's just a matter of filling in these figures, is equal to the sum of the heats of formation of the products multiplied by their coefficient. Just be careful there. You have one CO2, so I always like to put in the 1 anyway. 1 multiplied, because then we won't forget later. 1 multiplied, and then be careful the way that this is written. You see the way it's written that sort of way respectively. You wouldn't believe the amount of people get those mixed up. So carbon dioxide is first, so it's the first figure, minus 394. And then add that, because it's the sum of the coefficient of 2 multiplied by that of water. You see there's 2 waters there. So it's minus 286. And then you can close that big square bracket and subtract away from that the heat of formation of the reactants. Go over here. Well, methane is the one we don't know, but there's one of them, so 1 times X. And then water, or oxygen, sorry, is on its own, so it's 2 times 0, and then close that bracket. And then the next part would be to tidy everything up a little bit here, minus 940, so you could just, that's obviously minus 90.4, and then multiply that, that's minus 394, 1 times that, and then 2 times that, positive by negative is a negative, and then of course that will come out to be 572, multiplying the two of those together, and then close that bracket and subtract away. Well, 1 times X is of course X, and then 2 times 0 of course 0. You could tidy that up more. Minus 9.4 is equal to, and you could add the two of those together, and that would bring you up to what would that be, minus 966, and then you could subtract away from that X. You multiplying that X, get rid of that brackets, and you just have that value. So then you would add 966 to one side, so it's minus 890.4. Add 966 to the other side, and that'll give you minus X. Don't forget about the signs there, obviously this is very important. Then you could subtract the two of those, so it'll be 966 minus 890.4, and that will give you 75.6 is equal to minus X, and then of course you want to solve for positive X, so multiply this side by minus 1 and that side by minus 1, and you get 75.6. 75.6, and that's where that comes from. And I hope that is clear. So that gives you the heat of formation of methane.